Hello everyone and welcome to this session. In this session we're going to look at doing binary math. So what is binary math? Binary math is the way a computer converts a decimal number into ones and zeros. So computers can only read a 1 or a 0. These are what we call bits. A bit is the smallest amount of computer storage. So we either have an on condition or we have an off condition. The computer cannot, recognize the number 12. It actually has to have the number 12 converted into a binary digit. So we have to go through a process called binary math to convert a decimal number into a binary number. And the way they're going to do that is through a chart. Now the chart is, to me, is fairly straightforward. So we're going to start the chart at 1. All right, I'm going to show you a couple ways that you can remember that. So 1 doubled is 2, 2 doubled is 4, 4 doubled is 8, 16, 32, 64, and 128. Okay. Now, if you are the math oriented person, these numbers come from 2 to the 0 power, 2 to the first, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. So if you can't remember the doubling starting at 1, you can also do it by the exponent if you wish. So let's look at just a sample problem here. So these are our binary digits. The numbers may or may not look familiar to you, but these are storage values typically of thumb drives. So you get a 128 meg or gig thumb drive or whatnot. This is actually where storage numbers come from. Also, it's very common to see this with RAM. Okay. So let's do an easy one. Let's do something that, let's do one of these numbers right here across the top so you can actually see what it starts, how it looks. So we're going to use the number 64 is going to be our number that we are going to convert from decimal to binary. Okay? So the way that I have always taught this is how much money you have, and the numbers across here are how much money things cost, so what you want to buy essentially. So what we want to do is we want to convert this number 64 to binary. So you have $64. Can you buy something for $128 without using Visa, MasterCard, or American Express? The answer is no. So you're going to put a 0 there. Now if you have $64, can you buy something for $64? And the answer is yes. So we're going to take that number. So this is our starting number, and we're going to subtract it from the number we just used. Okay? And when you get to this, when you have nothing left over, the rest of the problem is 0. All right? So 64 represented in binary is 0, 1, 0, 0, 0, 0, 0, 0. So that would be the correct answer. One of the things I failed to mention here, if you count up all these boxes, this you'll count 8. All right, 8 bits. If you remember from your other computer classes, possibly, is 1 byte. So we're working at the byte level in these problems. So let's work another one. Let me step back before we do that. I'm going to show you a little trick here. 64, is it an even or an odd number? Even numbers are usually, 2, 4, 6, 8, and 0, right? They end in one of those. These are even numbers, and then odd numbers are everything else that come in between. Even numbers will always end in a 0. Why is that important? Because this is a quick way you can check your work. So if it's an even number and it ends in a 0, you have more than likely done the problem correctly. If it's an odd number and it ends in a 1, you've done the problem correctly. If it's an even number and it ends in a 1, you use something incorrectly here across the chart. So we're going to do another number that's not necessarily here in the binary chart. So let's look at, a lot of you out there are probably in your teens, so let's look at the number 18, okay? So if you're 18, so you have $18, can you buy something for $128? And the answer is no. How about 64? No. How about 32? No. How about 16? Yes. So we're going to do 18 minus 16, which is going to leave us with 2. So with $2 left, can we buy something for 8? No. How about 4? No. How about 2? Yes. And there you go, 18. We can do our check. 18 is an even number, and we did end in a 0, so that indicates that we are more than likely correct. Now, if you want to check your work, Windows Calculator will provide you with that functionality. If you go up to the top and you change it from scientific or regular or standard calculator to programmer mode, you can actually check this. The only thing you want to check, be sure of, is the Windows Calculator is going to give you this result right here, okay? And it's 1, 2, 3, 4, 5, right? Well, what that indicates is there's zeros up here, so that's 6, 7, 8. So be sure that when you're filling out your worksheet or on a quiz that you're putting these leading zeros in there, because we always go by 8. When I do the answer keys, always make sure that we're filling in at the whole byte level. So, how is this used? I mean, how does this work with a computer? I mean, computers need to take input that we give it. We need to give it the letter A, or a number, or a symbol, and it needs to be able to convert that out. How does that work? Well, it works through the process of what we call the Ascii code. So in your description, in the description of the video, or in the course itself, you'll have a link to an Ascii chart. Ascii is the American Standard Code for Information Exchange. Okay, so that is abbreviated to I's. Okay, so what we want to do is convert a name. So I'm going to put my name up here. Okay, so what we have to do on our Ascii chart, we're going to look up what an uppercase B is worth. In this case, decimal value for that is 66. A lowercase e, lowercase letters will always be higher, okay, higher in value. Like a lowercase a starts at 97. The uppercase letters start at 65. So a lower number would indicate an uppercase letter. E is 101, and a lowercase n is 110. So this is one of the little activities that you're going to get to do. So the first thing we have to do, we're just going to make this kind of an elongated chart here. So the first thing we're going to do is we're going to convert 66 into binary. Okay, works the same way as we've done in other previous videos. So we have $66. Can we buy something for $128? The answer to that is no. Can we buy something for $64? The answer to that is yes. So we have 66 minus 64. So that leaves us with 2. It's 4, 5, 6, right? So we have 2 left, so we can't buy anything for 32. We can't buy anything for 16. We can't buy anything for 8. We can't buy anything for 4, but we can buy something for 2. When you get to, like I said, when you get to the 0 condition, you are done, and we're going to put a 0 there. So this is what an uppercase B would look like in binary. So now let's do the math for 101. All right, so we have 101. We'll take this number away just to kind of get it out of the way. All right, so we have 101. Can we buy something for 128? No, we can't, but we can buy something for 64. So this is where your calculator will come in handy. So 101 minus 64, it leaves us with 37. So we have $37 left over. Can we buy something for 32? The answer is yes. 7, 6, 5 left, right? So we have $5 left. Can we buy something for 16? No. Can we buy something for 8? No. Can we buy something for 4? Yes. Can we buy something for 2? No. Can we buy something with 1? Yes. So here's your first odd number that we've come across. And the last number that we're going to work with is 110. So 110 is an even number, right? So let's start over here just so we can keep track of what we've done. We'll extend our chart a little bit. Okay, so now we're going to do, let me change the color here. Now we're going to do 110. So can you buy something for 128? No, you can't. So that's going to be, we're not going to do anything there. Since we have 64, so we can subtract out 64. So we're going to put a 1 there. 110 minus 64 leaves us with 46. So if we have 46, can we buy something for 32? Yes, we can. 46 minus 32 leaves us with 14. If you do this enough, what you're going to see is like, oh, I can do 14. You know, I'll just put a 1 here, 1 here, and 1 here. Can you do that? Yes, you can. So if you've got to that point where you can actually see 14, then that is one way you can actually speed up your binary math problem. So 14, can you buy something for 16? No. Can you buy something with 8? Yes. So 14 minus 8 leaves us with 6. So can we buy something for 4? Yes, we can. Leaves us with 2. All right. So we ended in a 0. That's an even number. So this is the way the computer would actually see my first name as this series of 1s and 0s. So every time you hit a key on the keyboard is converting each keystroke into binary string. So this is how the computer represents data as far as what the processor sees. All right, that's a lot of work that your keyboard's doing. It took us a long time to do that. Just think when you're typing 30, 40, 50 words a minute, how fast that keyboard controller is taking this data in. So, some tricks I'm going to show you here. The tricks involve maximum numbers that we can use here. So the maximum number that we can have in a byte is the sum of all of these numbers, which comes out to be 255. So what that means is 255 would be represented by all ones. Okay. Now I'm going to show you another trick. This one may be helpful to you and can help you with checking your work, essentially. So we knew 255, of course, was an odd number, and that's why we had the 1 there. What happens if you have a number that essentially bumps up against another one of these numbers? Let's say 63, for instance. Number one mistake that I'll see that students do is, for whatever reason, it doesn't process to them that this is 63, not 64. So I see this a lot. People will do this, and we're like, okay, so if you do the math behind that, you'd get a -1. Well, that would cause a pretty bad error, on a computer. We can't have a negative number. So if you come up with a negative number in your math, you've done something very, very wrong. And that's usually you've subtracted starting in the wrong column. So I'm going to show you the thing, the easy way here. So if you have a number, and it doesn't really matter which number it is here, that bumps up against another number, the answer is this. It will always be all ones up until that point. So if I gave you the number 31, it would be the same way. Okay, so if you kind of see a pattern there, so anytime you're bumping up against a number, you go one less than the number and you just fill it all in with ones. The way you check your binary math work is wherever the 1 appears, that's what you're going to add. So in this case, it would be 16 plus 8 plus 4 plus 2 plus 1. And if you get your calculator out, 16 plus 8 is 24, plus 4 is going to be 28, plus 2 is 30, plus 1 is 31. Okay, so there's you a quick little trick that you can use to do binary math, especially on problems that numbers that bounce up against another number. Some of you, let's do a simple one. Some of you may now see that you can do this in your head, especially with small numbers. So let's just say number 5. We want to convert the number 5 into binary. And if you look at your binary chart up here, you know that 4 plus 1 would give you 5, like that. So that's another way if you want to try to do binary math in your head. If you can just look up here, add up the sections that would make the number that you need, that is also a way that you can do it. You don't necessarily have to go the long way around if you don't want to, if you can look at it. But that's going to do it, guys, for binary math. I hope the little tricks and tips here help you on your future activities. Thank y'all for watching.